Composition of functions. Yeah, now I'm seeing myself on screen, and I look as silly as you think I look. Day 6, I don't know, it's day 6 or day 7, but it goes with worksheet 6. And today's the 19th, so that way I'll label it. You guys know that if you miss, I post the videos every day. I don't even have virtual students anymore, but that turned out to be a good help for people who missed. And occasionally, if there's a certain topic that you weren't sure about, there are students who go back and watch that video like the night before as a review for studying. So again, I don't expect all of you to watch all the videos. I don't expect most of you to watch any of the videos. But if you're out or if you need more help, that's why they're there. All right, composition of functions. You've done this before, so hopefully this is a review. But we'll teach it from scratch, so even if it's pretty rusty, I think you'll be okay. F of g of x. So it's like a nested function thing. And as always, you work from the inside out. Work the innermost parentheses first and work your way out. There's another way to write it, though, that's kind of a fancier way. I think it's a more confusing way, but it is the fancier way. F of g of x, like that. And some teachers will say fog of x. It's not official math terminology, but most math teachers would know what you're talking about if you said fog, or goth if it's the other way. But that's not multiplication, because it's not a dot. It's not an O, so it's not really fog, but it's just a small circle. And how we say it is F of g of x. F of g of x. And we'll do composition with numbers and with variables. And I don't know, I think the numbers are easier to work with, but some people think the variables are easier to work with. So f of x equals 2x squared plus 2. G of x equals x squared minus 5x plus 4. Those are example functions for us to work with. It's not like f and g are that for all time for this unit. So let's work an example. F of g of 2. Again, I don't like that notation because I don't find it as helpful. So I will usually rewrite it this way. Because when you write it as fog, it looks like you maybe should do the f function first. But when you write it as f of g of 2, I think it becomes a little more obvious that you need to do g of 2 first, because that's what's on the inside. So let's find g of 2. Whatever that is, we'll use that to plug in to f. So first thing we'll find is g of 2. So we grab the g function, and our input is 2. And the g function says square the input, and then do minus 5 times the input, and then add 4. So let's see, that would be 4 minus 10 plus 4. That would be negative 2. So g of 2 equals negative 2. Again, it's like a nested function thing. So we do the first function, do the inside function first. G of 2 is negative 2. Now that becomes the input to the f function. So I need to find the f function. F of negative 2. So negative 2 is our input. The f function says square it, multiply by 2, and add 2. So square of negative 2 is 4, times 2 is 8. 8 plus 2 is 10. So my answer is 10. So another one of those days where the computation stuff really isn't that hard. But the be careful stuff is where you can get messed up, and the notation stuff. So make sure you plug 2 into G. Don't accidentally plug it into F. There's just lots of little places for mistakes. Number 2, G of F of -1. So that means G of F of -1. Okay, you don't have to rewrite it. I think it's helpful to rewrite it, though. Why don't you try that one? See if you can take that one start to finish. So plug -1 into F, get an answer, and then plug that into G. So there's the answer to G of F of -1. Find F of -1 and get 4, and then that becomes your input to the G function. So you plug 4 into G, and you get 0. Let's try one more of this type, because sometimes this messes people up. F of 0. So F of 0. What do you think we should find first?
F of 0.
F of 0. So F of 0, that's pretty easy. 2 times 0 squared plus 2 is 2. What should we find next? F of 2. But just the fact that there's 2 F's there, sometimes that people are so used to, and I guess it's math teacher's fault, because we almost always do G of F or F of G, that if we put 2 F's in there, sometimes it messes people up. Let's see, 2 squared is 4, times 2 is 8, plus 2 is 10. Hopefully, not a big deal. What I think is a little bit harder, although some people prefer the variables to the numbers for whatever reason, is doing the same type of stuff without numbers, with just letters. So let's say F of X is x squared minus 2, and G of X is the square root of x minus 5. Let's find F of G of X. And again, I think it's easier if we write it the other way. F of G of X with parentheses. So G of X, there's nothing to evaluate there, right? I can't plug in 2 or 7 or anything. So I'm just going to take the whole G of X thing together, because I know what G of X is, and do F of square root x minus 5. So I'm going to take my F function, whatever is in the input goes in on the other side. You may notice I write it like that a lot, the order, because that sort of emphasizes to me I've kicked out the x, and I'm going to replace it with square root of x minus 5. Let's pause there for a second, because it feels like we could just wipe that out, like the square and the square root would cancel each other out. And that's only kind of true. This is a little bit tricky. I'll phrase it this way. If you square something, what kind of answer do you expect to get? Always positive. You square something, you're always going to get positive. Now, if you skip ahead and just say, well, the square and the square root cancels each other out, I'll just go with that. It's like, well, you might get a negative number out of that. If you plugged in x equals 2, 2 minus 5 is negative 3. Ignore this for now, this other part. But if I plugged in 2 up there, I get negative 3, I square root, I get an I square it, it gets back to negative 3. So I need to preserve the fact that my answer is always going to be positive. So squaring a square root, always positive. If only there was some mathematical operation that meant always positive. Absolute value. So this is a little bit strange, but the square root of x squared is the absolute value of x. Well, it doesn't really matter. You could also square the square root. It's the absolute value of x. I'm not worried about it. You can kind of cheat your way around it if instead of simplifying, you leave it like that. Now, on a multiple choice test, we can force you to simplify, but on a multiple choice test, that would have to be one of the answers. And hopefully, as you're reading through the answers, even if you wouldn't have remembered to do it, by seeing it as an answer choice, hopefully you'd think, oh yeah, that's what's going on here. Yuli?
If the 5 is positive in the inside, would you have to put the absolute value?
Yes, you still would. Good question. If this was x plus 5, because what if you plugged in negative 7? You would want, you wouldn't want your answer to end up negative. So that's a little bit strange, but you can leave it as the original if you don't want to mess with it. But multiple choice, you better be able to recognize that. Now, in a similar, let's talk about domain of f of g of x, or any composition of functions. The main thing is ooh, my computer survived enough to keep recording. So, internet's probably gone, but I'll post it later. Find the domain before simplifying. Feels like the air may have gone off as well. We'll see. It starts getting warm in the whole building. So, before simplifying is when you have to find the domain. So as soon as you do the plug-in, then you got to look for domain. So before simplifying would be up there. Square root of x minus 5 squared minus 2. Well, let's do a little trip down memory lane here. There's only 2 things we're worried about with domain. Do you remember what those 2 things are? Only 2 things you're looking for if we ask you for domain. What's that? Oh, you're like, thank you. 2 things you're looking for. 2 things you can't do.
Square roots can't be negative and fractions can't divide by 0.
Yep. Can't divide by 0. That's obviously not an issue here, but that is one of the issues on the worksheet today. And you can't square root a negative number. So before we undo the square roots and sort of lose track of it, which means we've got to check the domain before simplifying, we grab what's under the square root and say it has to be greater than or equal to 0. X has to be greater than or equal to 5. So 5 comma infinity is the domain. So the big thing though is before simplifying. So make the, plug it in, do the f of g, but before you start moving things around, adding, subtracting, squaring, pause where you're at after you make the substitution and answer the domain question, and then simplify if you can, if it will. All right, let's do the other way. Instead of f of g, let's do g of f of x. Again, that's the same thing as g of f of x. You say them the same way, so you got to look at what I'm writing. But those are identical. G of f of x.
The bottom of the last one real quick.
Oh yeah, sorry. So our domain 5 to infinity, because we can't square root a negative number. You're welcome. Nope, stay there for a minute. Good. I want to change up what f and g are to make a little bit different point on this one. So let's let f of x be x squared minus 2 and g of x be the square root of x plus 5. So g of x squared minus 2, because that's what f of x is. So I look at my g function. The g function is the square root of whatever the input is plus 5. So that's sort of the answer. That's an easy cleanup job. X squared plus 3 under the square root. Can't really do anything more with that, but let's find the domain. So whatever's under the radical, and again I'm going to go back to before we simplify. Although for this particular one it would have been okay to grab the simplified version. X squared plus 3 greater than or equal to 0. So if I want x squared plus 3 to be greater than or equal to 0, you answered this earlier. What type of number do I get when I square something? Positive. Maybe 0 though, so be careful. But then if I add 3 to it, this is going to always be positive. Which means this statement is always true. Which means it doesn't matter what x is. Because if we square it and add 3, we can put in anything we like and be able to square root it. So my domain for this one would be all real numbers. So a couple of tricky domain things going on when we start combining functions. Or doing composite functions. Right, let's look at worksheet 6 and do a couple of those together to make sure we're okay. So grab worksheet 6. And look at 6a, f plus g of 2. What do you think we do to find that?
X squared plus 1 plus whatever g of 2 is?
Kind of. Well, there's actually two ways to do it. You can do, you can add the f and g and then plug in 2, or what most people find a little easier is to just find f of 2 and g of 2 and add them together. Probably the easier way to go. So let's see, 2 squared plus 1 would be 5. 2 minus 4 is negative 2. So the answer is 3. Yet again, the computation isn't hard. It's more about the notation to know what it's asking you to do. All right, the rest pretty similar to what we've seen. I do want to fast forward to number 6. We'll do 6a and 6c. So again, f plus g of 3 means f of 3 plus g of 3. And I don't know why. Students can do f of 3 if they have an equation. They know that just means plug 3 in for x and see what you get. But somehow f of 3 with a graph becomes difficult. That 3, is that an x value or a y value?
X value.
That's an x value. But f of 3, what is that? Is that an x value or a y value? It's a y value. So this means when x is 3, what is y on the f function? So we look at the f function. Again, with 2 graphs, make sure you're looking at the right picture. Looking at the f function, when x is 3 on the f function, what's y equal to? 2. It's that point right there. So we'll have 2 plus, and then we kind of go through the same thing. X is 3, so we want the y value when x is 3, but this time we need to be on the g function. So what's the y value when x is 3? 1. So again, the computation part of today is easy. 2 plus 1 is 3. So using the graph to find answers. It's actually easier than plugging things in, but you got to know what you're looking for. And then part C, f of g of 2. So again, work from the inside out. G of 2. What's g of 2 equal to? 2. So there's g of 2 right there. And then f of 2. So g of 2 is equal to 2. That becomes the input to f. So again, just be careful. Make sure you're looking at the right graph. So I'm looking at the graph of f, and I plug in x equals 2. What's the y value when x is 2? 0. F of 2 equals 0. Okay, we made it. Electricity can go to poof now and we'd be good. Assignment is worksheet 6, the one we're working on. It'll be due next block day when our test is. I will have the worksheets that you submitted today. I'll have those graded for Monday so I can hand those back to you so you can start reviewing them at some point, maybe, for the test next week.